Clear? Okay. Welcome to today's session. It's about advanced data migration for RDS. So as people are streaming in, I guess, just a show of hands, how many of you here already use RDS? Wow, that's my people. All right, and how many of you have like in-flight projects for migration, things that you're working on right now? Almost all of you. Very nice. So very appropriate topic for everybody, I guess. How many MySQL? Okay, Oracle? And SQL Server? Okay, so some of you at least have multiple projects going on then, I guess. And how many DBAs here? Okay, so the others I'm guessing are ops people, infrastructure, management. Okay, very nice. So we have a lot of content to cover today, and I'm not sure how much we'll get through and leave enough time for Q&A. So just a heads up here, if we don't have enough time and we can't cover your questions right here, then I'd advise you, we have a booth called Database Services in the reInvent Central area. So please head over there, and we'll have our presenters be available. There's a whole bunch of more people there, and they should be able to answer all your questions around RDS and data migration and so on. So heading into the slides here, in the next hour, what we're covering is a bit of an overview. You're already using RDS, so you're aware of it, but I'll just cover what's new in RDS in the past couple months. Talk about the types of data migration that we're thinking of, that we want to support, that we know customers are using, and we'd like to enable for our customers and users. Talk about some general considerations around what goes into a migration project, and like probably 3/4 of you here have indicated you are doing migration, so you're already thinking of this. We're just laying it out on a slide here. And then, so I'm the first presenter. We've got two more presenters after me. One will cover, Abdul, he'll cover advanced data migration techniques for Oracle. And then we'll have Bernie come in to cover MySQL as well. So what's new, what's recent? For folks who use Oracle, you should know we launched support for Oracle Transparent Data Encryption. We do TDE with Amazon managed keys at the moment. But that's out, that's available. If you have requirements around encryption for Oracle, that's available. We launched MySQL 5.6, so you can launch new instances of 5.6. And then we made it available on our largest instance, which is the CR18XL. So that's 32 vCPUs, that's over 240 gigabytes of memory, very powerful machine. And then, you know, combine that with provisioned IOPS, 3 terabytes of storage, 30,000 IOPS. It should, we believe, meet the bulk, the majority of the use cases out there for production, for high availability, for mission critical type workloads. And essentially, that's where we're going. Bigger instances, larger instances, support for cross-region. So on the last bullet there, you'll see cross-region snapshot copy. So exciting things coming there as well, but this is what's already available. Support for Oracle StatsPack. So if you have AWR snapshots that you want to take and run reporting off of that, you can do that. The one thing that this slide does not capture, because it had to be embargoed before we released it, was SQL Server TDE. So besides Oracle, we'll now support encryption for SQL Server as well. So that's just recapping what's available, what's new. And then stay tuned. We've got a lot of exciting announcements coming up in tomorrow's keynote as well. So going to types of data migration. Now, obviously, a lot of people here are doing it. I'm just kind of reiterating what's already known to folks here. It's not new ground that we're covering here, but think of a migration project as almost akin to you moving from one place to another, right? That there's a lot of things that you need to consider. Is it a one-time migration? Do you just move house from one place to another? Are you constantly traveling back and forth? So there are interesting corollaries there. But a one-time migration could be the first step you do in a longer project, which actually eventually ends up doing replication, or it could be the end all, right? It could be that you just migrate from wherever your production is running right now into the cloud. So that's one type of migration. You copy your entire database and possibly the applications as well into the cloud itself. And use cases, like I said, would be migrate production to RDS. It could be that you want to build POCs or pilots. It could be possibly the first step, or it could be The first step, after which you will do incremental migrations, right? So that's one-time migration. The second would be periodic, where you did this one time, but then that's not enough. That's just one snapshot that you copied over to the cloud. And then after that, you want to bring in incremental changes into the cloud. And that could be because you want to do reporting or BI type activities on RDS, maybe. It could be because you are running production somewhere, but you want to do dev test in RDS, and so you want to bring in Delta type changes. And the reason I'm going through these kind of use cases is because I want to make sure everybody understands our intention with RDS is to enable all these use cases. Now, there are some which work better right now and some that don't. But all those features, if they're not right now available, they're definitely coming. And then obviously the last one, which is possibly the most technically challenging sometimes, but also something that people need a lot, use a lot, is ongoing replication. So you might have done a one-time migration up front, but then you want to keep that RDS database in sync with something else. It could be an EC2 instance, it could be your on-prem database, it could be a database in another region altogether. And then obviously support this for everything, for Oracle, MySQL, SQL Server. And like I said, we don't support all of these right now, but then we'll cover more about what's available with MySQL in the third session today with Bernie. But the way you do ongoing replication would be you somehow get the Delta changes up, right? You either do log shipping or some kind of transactional replication. And the use cases you're trying to support with that are some kind of BI reporting, query offloading type thing, or you are possibly doing a migration project, but where you're sensitive to downtime. You've got production running on EC2 or on-prem or in a colo, and as you are migrating, you don't want to take extensive downtime. So you want the first stage to be that you brought in a snapshot, you want an ongoing replication going on, and then when you're comfortable, at that point, you switch over your applications to point to RDS, and with minimum downtime, you can achieve that migration. So having gone over that, what do you need to think about? What do you need to consider? These are, again, just interesting questions. And like I said, you're probably thinking of them already. But just to go over them, and the reason you want to think about these more deeply is because you might now hit into constraints. You might hit into areas where you have to figure out if this migration project is feasible or do you need to change something around it. So the first one, obviously, is number of databases, size of databases. Current constraints around RDS are 3 terabytes of storage for Oracle and MySQL, and 1 terabyte for SQL Server. So essentially, if you're moving one instance from one place to another, the data's got to fit. That's the basic limitation that you need to address. Other things would be data types, character sets. Do you have unstructured data? Are you carrying over blobs? How do you exactly plan to move that data? What's the physical mechanism, right? Are you exporting a dump file? Is it flat files? Are you putting them into S3? Are you shipping us a device? There's an AWS export-import service, so you can give us a physical device, like a flash drive, mail it in, and we'll restore it for you on S3 or an EBS volume. So are you doing those? Are you moving data using some kind of FTP, SFTP, or Bernie will cover this, use some Tsunami, UDP type, or any other file transfer mechanism, right? So that itself needs to be thought through. What else is involved? It's typically never a database by itself, right? Nobody needs a database just for the sake of the database. You need it because there are applications that are consuming it. There are other databases that are linked up to it. There are reporting systems. So what else is involved in that project? And what's going to happen once this database moves over? You got to think about that. If there are links there, you got to think of that. And then any replication that you're doing or any FTP mechanism you're doing, you need to think about the networking implications. Do you need to punch holes through your firewall? Are proxy ports needed? How are you going to measure the bandwidth and the latency requirements around this? Can you physically actually move that much data in the available time? And with all this, obviously, there is the constraints around availability, around downtime. What is going on if it was a production environment, what's going on to the production environment while you are in flight, while you're moving your data? So all of these, depending on the answers you give to these questions, that would decide which mechanism you pick for data migration and how do you go about actually executing that project, right? And so this is kind of just an overview, and then obviously the second and third the other speakers will cover more in depth about actually how to do it with Oracle and MySQL. So in general, though, as you are migrating into RDS, there are a few best practices that you want to go over before you migrate, and then a few things that you want to do after you migrate. And these are applicable no matter which mechanism you use, no matter which engine, which database you're using. So the first thing is, if it's a big data load that you're doing, chances are you don't want applications constantly accessing that data. Now, obviously, if you have a use case that allows that and it's possible for you to handle that, that's fine. But a best practice would be don't have applications accessing your database while you're doing major uploads into the database, right? The other would be take a consistent snapshot before you begin this project, just in case something goes wrong and you need to roll back to a prior snapshot. You want to disable backups on that RDS instance, because backups typically involve running bin logs or running archive logs and other kinds of activities going on. And they're just slowing down your bulk data load. So disable backups before you do a major data upload or a migration. You want to use single AZ instances. Now this is, typically we advise customers that if you're running production or any kind of mission critical application, you use multi-AZ. But this is a special case where you're loading a lot of data and the standby is a synchronous replicated instance. So it's only going to slow you down. So for the duration of a bulk data upload, convert it into a single AZ instance, do your data load, and then if you want, you can go back to multi-AZ. And pick the right instance type for an upload. Now this might be different from what you need for running production or running dev test, right? You want to pick the beefiest instance that you want to use. You want to possibly use provisioned IOPS if you can. You want to take a look at where the instance placement is going to be. If there are staging machines involved, then you want to keep the EC2 staging instance in the same availability zone where the database is running. So basic stuff, but again, make a checklist and make sure you're going through all these. It's like a migration project. If you want another analogy, it's like a plane taking off, right? Even though everybody knows these are the steps you need to go through, sometimes people forget. So having a checklist is always a great idea. And then security configuration for migration can be different from what you need for running regular production. So you might have to open up more security rules. You might have to allow access to some other machines for staging or for database links or for your on-site database or something. So the configuration might have to change before you do a migration. Now, obviously, the moment you're done with a migration project, you want to turn back your backups. You want to go back to multi-AZ. If you were running MySQL, then at this point, you want to start up your replicas because there was no point running replicas during a major load. Tighten down that security again. You might have opened up holes and ports in your security group. You want to go back and close them. You might want to enable notifications using CloudWatch at this point because you might want to get notified if your CPU spikes above 80% or you're within 90% of your allocated storage. So all good practices that you want to go back and take a look at that instance after you're done with the migration because there might be things that you need to put back in place which you might have disabled for a migration. So that's essentially all I have to cover, and then I'll invite Abdul to come up and talk about the Oracle migration steps.
Should be now? All right. I think pretty much everybody could hear me even without the mics. Very excited to see a lot of familiar faces that are, so excited about all the stuff that's happening here. And how did you like the 3 new service announcements we had for today? All right. So let's look into how we can better use the one we already have and most of you guys like and already using. Can I have a show of hands of how many of you guys have tried migrating more than 500 gigabytes of data, half a terabyte of data? Wow, quite a few people. So one of the things that we heard from a lot of people is, especially after we moved from a 1 terabyte limit for RDS to 3 terabyte limit, now people want to move more data. It's not really small databases anymore. And most of the people want to move this data with minimal downtime. And most people want to do it on under 24 hours in one day or over a weekend. And we agree. That's the best way to do it. You know, when you want to have minimal interruptions to your business, and you want to do it when you can bring down your production so that you can move your data. So what I'm going to do here is basically show you how we can do it. It's kind of like a cooking demonstration, because the whole migration process takes a little while. I wouldn't be really able to do the demo here. So I put together a really nice process around how to move bulk data from your on-prem or your own data center to RDS instance. Most of the components of this process is something that you already know. Some of them you probably wouldn't, but many of you might not have really lined things up this way till this point to do it this way. One of the things that I have seen with many of our customers coming from where they are doing things on their own servers, their own data centers, on-prem, sometimes people don't really remember you could do things differently on AWS. AWS is quite a bit about not having constraints, right? So it's okay to spin up 15 instances at a time if you have to, right? If you have 15 really huge data files that you're trying to compress, you don't have to do it one by one. You have to do that in parallel. And you have to bring them together into a database. So we are actually going to leverage a lot of parallelism and multi-threading. So how about a 500 gig database? So that's what we are going to do. So we'll move 500 gig database from on-prem server to RDS. And when I was doing it, I was actually doing this on my desktop, which is an i7 with 4 cores. So you guys should be able to do this much better, right? So this is my database. I brought up a database, pumped up a bunch of data. We have 502 gigabytes of data in there. We'll take this data from the Oracle database running on my desktop all the way into RDS and see how quickly, how efficiently we can do this so you can replicate the same process. The reason I picked 500 gigabytes is that seems to be kind of like the sweet spot. Many people have more. So if we can do this in an acceptable amount of time, you can probably extrapolate and figure out how much longer it's going to take you for 2 terabytes of data, right? And then the other thing is, Shakil touched upon this a little bit, moving data is kind of like moving homes, right? So one of the things that you do when you move homes is you throw away the stuff that you don't need, right? And you probably donate a bunch of stuff. I'm not recommending you donate your data, but avoid the data that you don't need to move. A lot of times, depending on how well-tuned your database is for a particular purpose, like databases that are more for reporting, that kind of purposes, which is kind of like where you have fewer inserts and updates and more selects, you'll see a lot of indexes. And I have seen databases in which the index size, the amount of indexes is so big that it's like half the size of the database. You don't really need to move indexes. You can bring the data over to RDS and you can rebuild the indexes, right? It all depends on how exactly you want to do it. So consider all these things. Avoid data that you don't need to move. Avoid indexes that doesn't need to be moved. And also try to figure out if it's okay to move the data in parts, in chunks. Many times, depending on what you are using your database for, people use the same database for multiple applications. So each application uses its own schema. So you don't need to move the entire database. Maybe you are moving your application one by one, so you can move the schemas one by one, right? So figure out what is the best way to move data. So if you, let's say, have a 1 terabyte database, if you apply most of the things that I mentioned so far, it might come down to our 500 gig database, right? So let's see the process of migration, how exactly we are going to do it. What you're seeing there is actually the on-prem, your own data center. You have the Oracle database sitting there. So we are setting up our VPC. Within the VPC, we have an RDS Oracle instance running. And like Shakil was a little shy to tell you to pick the largest instance possible. He said the optimal instance. I'll tell you to pick the largest instance. because you are going to do this only for a little while till the migration is done, right? 6 hours, 8 hours, 24 hours, whatever it is. So your cost for that size of instance is only for that period of time. Then you can cut down to whatever your actual size is. So in addition to our RDS instance, we'll set up an EC2 instance. This is going to be our bridge instance or staging instance. We are going to get your data from your existing database into this EC2 instance. You'll see in a little bit why we want to do it that way. And then from there to the RDS instance. The main reason I'm doing it this way is you don't have access directly to the box where RDS is running, right? You don't have operating system level access. So you cannot get date files over there. So some of the methods we have on our documents on how to migrate data to RDS is using database links, right? Using import export or using data bump export in the network mode. We are actually going to do in a file mode. So we need to move files to the RDS instance. Unfortunately, we cannot do that at the operating system level. So we are going to use this bridge instance in between to get you there. So the first part of doing this whole thing is actually doing the data bump export in your on-prem instance. So we did that. Our database, our storage is full with the files that we need. We move those files. We find out the best way to move those files to the EC2 instance. Then from the EC2 instance, we move those files to the RDS instance, then import that into the RDS. So this is the first part of the whole process. We use Oracle Data Pump Export. Data Pump Export is a very, very powerful tool. It lets you pick and choose the kind of data that you want. In this case, you can see I said full is equal to Y means I'm exporting the entire database. You can select a particular schema or a bunch of tables, or you can even use a query to cut down the amount of data that you want to bring in, right? Couple of other key things you need to pay attention to. There is the parallelism. I'm using this in a multi-threaded fashion. We're saying parallel is equal to 8, so 8 processes is going to work on this together. And compression, very, very, very important. You compress your data before you get into the file. So I'm saying compress the data. So when I'm done with all this, my total database, the data size that I'm getting out of the database is going to be much smaller than the actual data. So this is a screenshot of me kicking off the process. You can see actually started the process at 15:18:51. That's the time the process started. And I'll let it run multi-threaded. I have 8 threads going, creating 3 files at a time because you probably noticed in the picture, I actually had 3 disks on my desktop. So because I had 3 disks, I have 3 independent I/O subsystems. I want to leverage that. Maybe your server has 7 disks, then you do 7 files at the same time. So it's all about really utilizing what you already have. So I'm creating 3 files at a time using 8 threads, and I got started at 15:18. And 17:36, I'm done exporting our 500 gigs of data. So that is 2 hours and 18 minutes. So that's all it took me to export 500 gigs of data. So I got that 500 gigs of data, and now I need to move this from my on-prem database over to the EC2 instance, right? That's my 175 gigs of data from the 18 files that we have. So my 500 gigs of database from export and the compression came down to 18 files, totaling 175 gigs. So now I move this 175 gigs to my EC2 instance. What I did was I used a UDP-based tool called Tsunami. This is, again, optimizing that part of your process. You don't want to use FTP or SFTP or something because it's going to use a very tiny part of your network bandwidth. So what we want to do is we want to saturate our network bandwidth. We want to make use of every piece of bandwidth we have available so that we can move whole chunks of data in parallel. Because we want to get it there as soon as possible, right? We want to get it done within our 24-hour window that we originally talked about. So this Tsunami is an open source tool. You can just Google it or use the URL that's in that slide to go get it. There are many other similar commercially available tools like Aspera or there are WAN optimizers like Riverbed, Whitewater. You can use any one of these. I just choose to use Tsunami. So this is how you install and compile Tsunami. Once that is done, make sure you have the right port open to get the data out. Very, very important. So once that is done, the next step is to go to install the Tsunami on both the source server, where I'm getting the data out from, as well as in my target server. My target server in this case is the EC2 instance, right? So what kind of EC2 instance would you pick? Who will pick the smallest EC2 instance? Show of hands. Who would pick the largest EC2 instance? Yep, that's what we want, because we are going to use this only for a few hours, right? And this Tsunami is quite darn demanding. I think that's why it's called Tsunami, right? So you want to use the largest possible instance with multiple EBS volume. So, again, independent I/O subsystem, so you can write multiple files at the same time. So you want to install Tsunami on the source side, which is on your on-prem database instance, as well as we want to install the same thing in the EC2 instance. So now one acts as a server and the other acts as a client. So we are going to get the data from the source, the files from the source, all the way into the destination, which is our EC2 instance. Now, you remember we saw 18 files that were kind of like spit up from our original database, right? From our source Oracle database. And we were doing 3 files at a time. I told you I picked 3 files at a time because I had 3 independent hard disks. So I didn't wait for all the 18 files to come out. It's not like, it's like you don't have to wait for all the cakes to be baked before you start eating, right? As soon as the first 3 files came out, I started moving it using Tsunami. So again, parallelism, right? You can do multiple things in parallel. You don't have to wait for the whole process, one step to be done to start the next one. So the first 3 came in, I'm moving into EC2. The next 3 comes, moving into EC2. Moving this 175 gigs of data using UDP, using Tsunami, took me 2 hours and 23 minutes. Isn't that cool? When I do the same thing using SFTP, it takes me about 38 hours. So that's a good amount of difference, right? So I got the 175 gigs now in my EC2 instance, my large EC2 instance, right? Here is something that you need to keep in mind if you do not know. I don't know if you have enough documentation around this already. We have a directory, this is called the Oracle directory object in the RDS instance called data_pump_dir. So this is the directory that you can access outside of RDS instance. Though you don't have access directly at the operating system level, this is a directory where you can write and read files from in the RDS instance. So this is what we are going to really make use of. So what I'm going to talk about is migrating data to RDS, right? So what we'll be looking into is moving these files into the RDS instance. You can actually make use of this directory to also get data out of your RDS instance. I'm not going to talk about it, but just keep in mind. So this is a very good friend of yours. I'm going to use this Perl script. It's a very simple Perl script. Oh, by the way, actually, next Wednesday, you'll get all the decks of all these sessions that you have attended as PDF files. So all this is going to be available to you if you want to make use of it. So this is basically a single Perl script. All that it does is it reads the file that we move to the EC2 instance and writes it out to the, which directory that I talked about? Yes, the data file out directory, right? It gets into the data file out directory. But this is what Perl does is we are actually using Oracle UTL file package to do the operation, because what we are doing is not moving the files at the operating system level. We are using this using Oracle technology. So there's a UTL file package that Oracle provides. We are using that to move this data into the Oracle directory object. So that's the rest of the code. So I'm just opening up, reading the files, one chunk at a time, and moving it to the RDS file. Now, if I'm doing this one file at a time, it's again going to take me a while, right? Because this is a single-threaded process. This is my own script. I'm actually doing a little bit of chunk at a time and moving, in a serial fashion. So this is going to take a while if I do it one after the other. So the best way for you to do this would be spinning up multiple of these scripts. So you can run it in the background, run that script with the name of the file that we want to move. And again, you don't have to wait for Tsunami to bring in all the files over here, right? So the way I did it was I started the export of the database using data pump export. I'm going to eventually get 18 files, but as soon as I got 3 files, I kicked off Tsunami to move those 3 files to the EC2 instance. As soon as those 3 files came to the EC2 instance, I started off my Perl script to move those files into the RDS instance, right? At the same time, there's still data export happening from the database. At the same time, there's more file coming through Tsunami. So now we have all these 3 files moving in parallel. So how long it took me? It took me 3 hours and 19 minutes to get this from the EC2 instance into the RDS instance. Keep in mind, this is the total time it took me for that particular process. That doesn't mean it is the time that is taken from after the previous process, because we are doing it in parallel, right? So now our files are in the RDS instance. Once the files are in the RDS instance, now I need to use the same process, the opposite of the process that I used in the first place to get the data out from an Oracle database. So I use Oracle Data Pump Export to export the data out of the Oracle database in the first place. Now I moved that data to our target database. The next thing I want to do is use the opposite of it, the import process, to get the data into the RDS Oracle database, right? So what I'm going to do is write a little bit of a PL SQL script, which uses the Oracle's technology, Oracle Data Pump. So just like UTL file, Oracle provides a package called DBMS Data Pump. You can call different functions in this package to do the same thing that you can do from a shell script or from the data pump export utility command line. So you can use this PL SQL package to achieve the same thing. So I'm going to run this PL SQL package. This PL SQL package is going to work on the files that I imported. This is going just like we did first. We did a parallel import from we use 8 threads. We can do the same thing here as well. We can have a multi-threaded import. So once I kick this off, I'm going to get all the data into the RDS instance. So that took me 3 hours and 49 minutes. So how much did it take me in total? Because I was doing these things in parallel, it took me 6 hours and 42 minutes to move 500 gigs of data from my on-prem Oracle database into RDS database. Who thinks that's cool? All right. So that's 500 gigs of data, right? So if you have 2 terabytes of data to move, it's probably going to take you 4 times this time, maybe less. So even if you try to move 4 terabytes of data, once you chop off the stuff that you don't need, you can still get it all done within 24 hours. Just make sure you follow the same methodology, you do things in parallel, you use multi-threaded processes. So one of the things that in that import-export process, I use the compression to get compressed data. That's how we got 500 gigs down to 175 gigs. You can use compression that way only if you are using Oracle Database Enterprise version. Since a lot of our customers who use RDS use Oracle Database Standard version, I think many of you might be using standard version currently and want to make use of the export-import process available there. So if you're using standard version, you won't be able to do compress is equal to y. You could do it, the engine will ignore it, so it won't get compressed. So in that case, you are going to have to get the files out first, then you'll have to compress it yourself, right? You'll need to zip it. So do not move the files using UDP or whatever tool of your choice without compressing the files. It's very important to compress the files. That's one of the main part of cutting down the amount of time, right? Again, use a zip utility to compress it, but I would suggest you do not use the regular zip or gzip, because those are single-threaded process. So once you get out of this room, there are 2 things I want to put in, keep in your head. One is parallelism and compression. We want to achieve both of these things together to stay within our time limit, right? So if you don't have enterprise edition to compress the file, you want to use any utility that's multi-threaded. So there are a bunch of other zipping utilities available like bzip2 or 7zip or pigz. So use one of these. Again, do not wait for all the files to come out. As soon as the first chunk of files comes out, you start compression, right? So you're running multiple compression processes in parallel so you can cut down the total amount of time. Now, once you get this data over to EC2, now you have to decompress it, right? You have to uncompress it before you can move the data to the RDS instance, right? So that process you need to do a little different than what I showed you. In our case, since the files are compressed by the export process itself, the data pump itself, when you import it using data pump knows that this is compressed data and it knows how to uncompress it before it writes into the database, right? When you are actually not using data pump compression, you are going to do it yourself and you are going to uncompress it before you get it over to RDS, right? Now let's say you got this 18 files into EC2. Again, if you are going to uncompress it on EC2, it's going to take you a while. But since you can spin up multiple EC2 instances, I would suggest you do it that way. So once you have all the files compressed in the source, instead of using one EC2 instance like I used, you use 18 EC2 instances and you run Tsunami there. Each EC2 instance picks one file and all of them uncompress them in parallel and all of them are pushing into RDS in parallel. So parallelism and compression, the two very key part of this whole process. Just to summarize everything that I said so far, so reduce the data set to the optimal size, compression and parallel processing, and independent I/O. So when it comes to, pick the number of files based on the number of disks you have. On the EC2 side, also pick multiple EBS volumes, and make sure you choose PIOPS EBS volumes, nothing else, PIOPS. You could also pick your EC2 instance with SSDs, like high I/O instance, right? So depending on the size of your file, and you can make use of the local disk. And for data upload, I would strongly suggest Tsunami, but if you find something better, you could use that as well, and let me know. And when it comes to data upload again, pick the largest possible RDS instance. You can always scale it down. Once the process is done, Shakil covered a lot of pre and post migration steps. There are some of the things that you need to do before migration, like turning off the backup and make it into single AAC and whatnot. So once you're done with that, one of the next things to do with go scale up the instance. Once you get the largest type of instance, you start your migration. When you're done with your migration, scale it down. So now we are done with a one-time load of data, right? A lot of times, one time is not enough because by the time you are done with the data upload, some data might have changed. So you want to do some periodic update as well. So for this, you can use our all well-documented processes using data pump network mode or materialized views or even your custom triggers. So now we are talking about moving a little bit of data. You moved 500 gigs of data. After I moved 500 gigs of data, the changed data is probably like, 20 megabytes or 200 megabytes. Compared to the data that we moved, this is pretty small. So you can either use the data pump network mode operation, or you can use custom triggers to move the data, or you can use something like Golden Gate. So Golden Gate is again something a lot of people ask us about for real-time replication. Even when people want to use RDS as the reporting instance or a DR instance, or a geo-redundant instance, something like that. So we want to keep the data in your production instance in sync with the RDS instance, right? The best way to do that is using some tool that'll move data in real time. But even moving data in real time, first you want to do an initial load of the existing data, right? You cannot really move the existing 2 terabytes of data in real time. So take a little bit of downtime, like what we mentioned, so you can export all the data up and bring it to RDS. Now your existing data is in RDS. Then you can use something like Golden Gate to continually move data into RDS. So this opens up a whole new set of capabilities for you. Now you can have multiple databases for doing different things. You can have your production database where you are doing all your OLTP operations. You'll have a replicated database using Golden Gate where you could be doing your reporting and analytics and whatnot. If you're everything that I mentioned so far, again, keep in mind this is for large data sets, right? Because there's a bunch of things that you need to do to get the data over here. So if your database is pretty small, you don't need to do any of this. So what is small? It's kind of like a very relative, right? It's kind of like the largest span size that was available in Gulliver's Island was probably small for Gulliver, right? So depending on the amount of data that you have, whether you have data direct connect or the latency of your network, the bandwidth you have, the small size means different things for different people. So I would say anything between like 10 megabytes to a couple of 100 megabytes of data, you don't need to use the process that I outlined. So you can use any one of these. You can use the Oracle import export or data from network mode or SQL loader or materialized views. Materialized views is a very, very efficient way of getting data synchronized and data moved from small data sets moved from your existing database to RDS. And with that, I'd like to invite my colleague Bernie to take you through the same process for MySQL, and it's more exciting there.
Can you guys hear me? Yeah. So Abdul covered the migrating approaches for Oracle. So in the next 15 minutes, what I'll be doing is I'll be walking you through the migration approaches for MySQL with really less downtime. Minimal downtime is what we're going to talk about, which I'm going to cover. I mean, let's say you have an application with a database, with a MySQL database on premise. So we try to, the use case that I used and the demo that I had, which we're going to be doing some screenshots here, is something, so we take a MySQL dump of your existing MySQL on your on-premise database using MySQL dump to a staging location. And then the key thing is having your network set up, the security configurations. Make sure there's 44026, the ports open on your firewall so that based on the protocols that you use, you punch those holes to migrate this. And then create, choose a region of your choice, and then have an EC2 staging instance. Because we're gonna follow through the same approach of using using a staging EC2 instance to migrate the MySQL dump from on-premise into that EC2 instance. As Abdul mentioned, make sure you have an EC2 instance that's big enough, and then try to choose between two things. One is an instance that has ephemeral storage, which has the SSD drives, is one option. The second option is an EC2 instance with PIOPS, EBS volumes. So those are the two. In this case, I use the PIOPS on an EC2 instance. This will be your staging server, and then create an RDS MySQL database. And then move your staging, the MySQL dump, the backup of your on-premise MySQL into the staging server, right? We'll walk through a couple of things that I tried and then show you, which one that I did. In this case, it's SCP or Tsunami, any of that. And then once the transfer of the backup is done, we'll basically use the staging server to import the data into MySQL, the MySQL database in the RDS. Once we do that, once the load is done, we make the on-premise database as the master database, and then configure the MySQL RDS instance as a slave instance. And then we enable replication, right? So that there's a delta between the time between you started your backup, and then so that you capture, I'll walk you through the process of the file, there's a SQL log bin file and the file number that you need to document. And once the replication is done, you migrate your application and then promote the slave to a master database so that you can have your application migrated to the cloud, okay? So importing, the master SQL database here is on premise. The changes are basically logged into events in the SQL binary log file. And the slave database retrieves these events when you enable replication between the master and the slave, and it will replay these events to bring the database up to the latest, right? So once we do that, importing, and then migrating this backup from on-premise to Amazon, so we went through multiple ways. I mean, I tried all the following. So the first one is use FTP or SCP on the wire. That can be slow. That can be really slow based on your pipe. And the second option we tried was the SFTP and SCP with the direct connect in place. You know, direct connect is a private connection that you have between the enterprise endpoint and the Amazon endpoint. And it gives you that point-to-point connection, you know, an expected throughput and a consistent latency, right? We tried that. And then the next option we tried was the Tsunami UDP, which is a UDP-based protocol that it uses. And the next one is Aspera, was something that we thought we could use it, but I did not try that. The other option we tried is the storage gateway. You can deploy a storage gateway on-premise and then map your backup disk that you backed up the MySQL dump as the initiator, and then the S3 bucket in Amazon as the target. So that once the backup is done, you take a snapshot into S3, use that snapshot to mount as an EBS volume, and then mount that to your EC2 instance so that you can start the MySQL dump. The last one is import and export, where you can ship drives to Amazon. You know, we will import your data into an S3 bucket or an EBS volume. And then to improve performance, you know, you can always choose to use some of the WAN acceleration from Riverbed or Citrix or Archive, any of this, so that you can accelerate the migration. So here is a database called Bench, which is about 150 gig that we tried to migrate. I just want to run through a SQL command to show the size of the database. And then we ran the MySQL dump, where you take this and then create your MySQL dump on the on-premise database. And then, you know, went into Amazon Web Services and then created a MySQL, an RDS MySQL using console or CLI. In this case, I use a CLI to create the RDS instance. And then created the staging database, the staging server. I used the CLI to do that. Once you're done creating the MySQL database, the RDS MySQL and the EC2 staging, you go to the master and create a master user and grant access to select another application in the master database on premise. Right, once you do that, you basically update your etc my.config. This is where you start, you enable replication on your master database. The server ID and the bin log and the replay, these are the things that you update your file. This enables bin logging, which creates the file, the files that are recorded and the changes that have been occurred on the master database. So this is what you do on the master database. So once you do that, you restart your database and then log into the master database and then run the show master status. This is where you're going to document the file, the mysql.bin.0023, and the position of that. This is the position of your SQL, the bin logs. So document these two parameters that are shown on the screen. And once you have that, you can do multiple ways. You can tar the file, you can compress it, and then ship it to EC2 instance. In case, the best timing that I got on this 150 gig MySQL dump was using the UDP database, UDP protocol using Tsunami. It was about 2.5 hours. I was able to move that to the staging server. And then, on the staging server, make sure the security group is kind of, you update the EC2 security group so that you have the ports that are open, the protocols and ports open in order for that transfer to happen. And then on the EC2 instance, make sure you untar the file. And then on the RDS database, log in and create the bench database. That's the first step. Once you create that, you take all the, we're doing this from the staging server, right? So from the staging server, use the load data local file to import these the data files that we have migrated from on-premise. So once you do that, you configure the MySQL RDS as a slave database. And because we can, on a on-premise slave to enable it, we can always edit the my.config file and make that as a slave. Because RDS will not give you access, we don't have access to the operating system, we have a stored procedure called mysql.rds_set_external_master. So when you use this procedure, you can see we're setting an external master database as the master in the slave database. So here you give the name of the master server, the port at which it's running, and the replication user that we created on the master database and the password. And the key thing is the file that we documented, and then the and then the other parameters. So that with this, you can set the on-premise MySQL database as the master on the slave in RDS. Once you do that, you start the replication on your RDS. And then once you start the RDS, so this is a screenshot, you see it starts the replication. The RDS, this is the Amazon console where you have the RDS console up. The console will show that it's replicating, and once the changes, the deltas have been moved over into the slave database, you basically switch the RDS database. So I walk you through the steps here. You can stop the application service that's pointing to the master database, and then once all the changes have been applied to the RDS in MySQL, you can stop the replication by running the stored procedure MySQL.RDS stop replication. At this point, you're basically stopping the replication. And then once the migration is done, you kind of reset the external master and then promote the slave as your master, as your regular MySQL database, right? Yep, that's all. Please feel free to provide any feedback on the session. The slides will be available, as Abdul said, on Wednesday. And the feedback can be provided online as well as on your app. Thank you.